Hello, hello, student. I am audible. Okay, okay, fine. Let us wait few minutes. Just join another participant. Then we'll start within 5 minutes. Okay, I think 5 students already joined. Let us wait few minutes. Uh, yes, yes, please. Hello. Yes, Diksha. If you want to, hello, please, Kedar, you please switch off your audio. Please just unmute. Hello, Kedarnath, just switch off your audio. Yeah, now fine. Okay, now we'll start some question answer session. So many students already joined, around 13 students already joined. So let me move ahead. So basically, let me ask first. So I'm audible very in proper way. My audio is clear. Please anyone just tell me yes or write. You can write in the chat box also. Okay, okay, fine. Okay, so I want to move first with the questions, previous year questions. So so Screen is visible? The week 1 lecture, yeah, lecture 1, lecture 2 and lecture 3. So we will cover today the question regarding the lecture 1, basic concept of fluid and properties of fluid, and third lecture about the fluid flow analysis. So I think my entire screen is not visible to you. So let me unshare and let me share the entire screen. Now PPT is visible in full view mode. So basically I will follow these one book, Fluid Mechanics, Fundamental and Application, Sinjal and Simbala. So some basic concepts are there, but we'll not discuss here. Sir has already discussed lots of things. So directly we'll solve some questions regarding the week 1. So the first question is, in a Newtonian fluid, for a given shear stress, the rate at which fluid deform is, first option, the independent of kinematic viscosity, B option, directly proportional to the dynamic viscosity, C option, inversely proportional to the dynamic viscosity, and D option, none of the above. So which one is correct? Please just you can write in the comment box which option is correct for the first question. Then we'll move ahead on the second question. So please you need to write first. This is I think not possible. So please for first question Mukesh is telling option C and Azit is telling option B. Okay. Any other? Just please write ABCD in the chat box, or you can also you just open your mic and you can tell me. So in Newtonian fluid, we are talking about here the Newtonian fluid for a given shear stress. The rate at which the fluid is deformed, inversely proportional to the dynamic viscosity. Direct. Okay, option B is telling many of them. Solanki also is telling option B. Okay. Okay, so you know one formula. Tau is equal to mu by dy. So here your in Newtonian fluid for a given series, the rate at which fluid deform, is your inversely proportional to the dynamic viscosity. We are not talking here about the shear stress, whether it is directly proportional to or indirectly proportional to. We are talking about here the dynamic viscosity, or your the relation between dynamic viscosity and the rate of fluid deformation. Okay. So already I think I have some PPT regarding that. So not here. So it is inversely proportional to the dynamic viscosity. So for question, and how it is, because you know the fluid deformation, where if your viscosity will be more, your deformation rate will be less. So from here you can also, for your basic understanding, you can tell the answer of this first question. Now the question second, a control volume implies an isolated system, a fixed region in a space, a closed system, a specified mass of fluid flow. Which one is correct? For question number 2. Yes, please. For question number 2, which one is correct? Or I have a new questions also. Just please. Yes, anyone raising hand? Okay. Simranjit is telling option B is correct. A fixed region in a space. Okay. Another? Another student what want to tell? Okay, everyone telling is B. Okay. Option B is correct for the control volume. But in system, for a control system, let me discuss here some concept regarding the control volume and system. So actually your control volume is nothing but if water is flowing something, let's suppose in a channel, you are looking from the top view. So for analyzing or for deriving the equation, you need to consider a fixed region, and whatever the fluid is entering, whatever fluid will be out, you will be focused in this region only, how the changes happening on the fluid element. But for a system, not a control volume system, for a system, what you will do, consider a particular mass of the volume, and as the your mass will move, you will analyze that mass only. You will analyze that mass only. So this is the difference, control volume and system. Now moving ahead, next question. Uh, the condition of no slip at rigid boundary is applicable to option A, flow of Newtonian fluid only, flow of real fluids, flow of ideal fluid, and flow of non-Newtonian fluid. Which one is correct for option number for next question? Or you can say the question number 1 here also. So for this question, which option is correct? Slide is visible very clear. Please, anyone, just write yes or no. Okay, it means people giving the answer, it means slide is visible very well. So option D is correct. Someone telling option B. Okay. Now other participants just participate in the chat box. The condition of no slip at rigid boundary is applicable to flow of Newtonian fluid only, flow of all real fluids, flow of ideal fluid only, flow of non-Newtonian fluid only. Diksha is telling option D, and Samit is telling option B. Okay, for this option B is correct. It is applicable for all real fluids, no slip conditions. Always remember, please. Now the questions second what telling in this slide. Let me read. A control volume implies, okay, we have already discussed this question. Now the question number 3. Poise is a unit of dynamic viscosity, kinematic viscosity, vapor pressure, or the surface tension. Which option is correct for question number 3? Okay. Many students are telling option D. Solanki, you are telling the poise is a unit of surface tension or something else. Jasprit is telling option A, it means dynamic viscosity. Poise is a unit of dynamic viscosity. And someone write the dynamic viscosity unit in the SI unit? In SI system, anyone right? Okay, okay, Pascal second, that's good. Okay, that's good. Now let the answer of third question is A, dynamic viscosity. And how it will be dynamic viscosity, let me discuss for another student. Might be some student not able to get. So tau is equal to, you know already, dynamic viscosity and your change in velocity with respect to time. So this is what? This is Newton per meter square and your unit, and this is meter per second and again meter for y. This meter per second for velocity and this meter for y. So meter meter cancel. So your mu will be equal to Newton second per meter square. Newton second per meter square. So for this you can say Pascal a second, or you can also write this in terms of poise also in a SI unit. So now moving ahead on the next question. Next question is very very important. Match list 1 and list 2 and select the correct answer using the code given below. First, list 1 P, property which explain the spherical nature of a drop of fluid. Q, property which explain cavitation in the fluid flow. R, property which explain rise of water in tree. Property which explains flow of oil jet. List 2, viscosity, surface tension, compressibility, vapor pressure and the capillarity. Just please tell answer whether option A, B, C, D is correct. Which one is correct? This question little bit take more time, but please you try to give the correct answer for this question, because this is the basic question. Benito is telling option C is correct for that. Okay, another participant, just please try to give the answer in the chat box. And Smith is telling surface P is a surface tension. Okay, but you need to tell the all answers. Okay, anyone please? Sara also telling option C. Kedar also telling C. Solanki C. Okay, majority of students telling the option C is correct. Okay, let me check. For P, option 2, surface tension, and S, property which explain the flow of oil jet. Okay, property which explain the rise of water in the tree, that is capillary. So for R, your option 5 will be correct. For P, it is 2 or 3. Property which explain the spherical nature of drop in the fluid. Surface tension. Yes, option C is correct for that. Now moving ahead on the next question. Question number 4. Yes, please. Sure. Just please wait, just wait. Okay. Thank you for your question. Okay. So here is telling nothing but just for we'll focus on the whatever we have just for such type of question how we'll approach. First of all, we approach whatever we know very clearly. So for as per the my knowledge, I know the property which explain the rise of water in the capillary, rise of water in the tree, that is capillary. So for R, how you will approach, I will explain each one. So for capillary you will, for R you will go with the 5. So R is related to 5 here also and 5 here also. Okay. So your option A or option C? Maybe option A will be correct or option C. For S option A. S means property which explain flow of oil jet. Your A will be, for S A will be go. And another option Q. Q is the property which explain the cavitation in the fluid flow. It is with the question 4. Your Q is related to 4. That is the vapor pressure. You know already when the vapor pressure is that is your in go will in the minus, then what will be happen? Your cavitation phenomena will be happen. So when your atmospheric pressure go down the, let's suppose in a pipe water is flowing, when and your pressure is go down with the atmospheric pressure, what will happen? Your vapor pressure will be form and cavitation will be happen. So like that you will approach for. Okay. Now whether for P it will be 3 or 2. So how you will read? Property which explain the spherical nature of drop of fluid. So spherical nature of drop of fluid, I think you have gone through the lectures. So sir has explained lots of derivation regarding the your drop particle, liquid fluid particle or liquid particle. So always you know already the formula. The surface tension will involve like such type of that is your spherical nature of drop, the derivation of the spherical nature drop. So option P will be correct for that. Option P, your surface tension will be correct. So basically surface tension is what? If you want to know, I think sir has explained very well. So you can follow video also. So like that you will approach the answer such that is the for such type of questions for list 1 and list 2. So I think everyone know about the answer of this, the unit of dynamic viscosity, Newton second per meter square. So I have already discussed. Now moving ahead on the next question. With increase in, yes please. In gate exam. Or in gate exam, such type of question you can expect. Like, have you solved the previous year gate examination? Let me go ahead on the next question. Okay. Have you solved previous year gate questions? Okay, okay. You have already solved. So I think you have seen the some in the previous last few year back. So you know other participant give the answer of the question number 5. Another participant you can give. So Mukesh, you know already the in the first chapter your question come from the unit also, the dynamic viscosity unit, kinematic viscosity unit, also the which type on the properties of the fluid, that is your Newtonian fluid, the graph of the Newton, which type of graph follow the with respect to your deformation and the shear stress. So such type of question you can expect, and you can expect the question like previous also. That is the matching questions. Yes, 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 yes. So in the coming year, you cannot expect such type of questions because every year a question little bit different from the previous year. You, if you will see, yeah, yes. So now please for question 5 you can give the answer. With increase in temperature, with increase in temperature, viscosity of fluid, whether it will be decrease, does not change, always increase, always decrease, increase if the fluid is gas and decrease if the fluid is liquid. So option D, many student telling the option D. Okay, I think option D is correct. How it will be correct? Let me little bit. I will give conceptual concepts on question 5. So basically, in the for liquid, I will take water, and for gas, I will take air. So as you increase the temperature, what will be happen? The particle, the distance between the particle in case of water will be increase. The distance of the particle will be increase. But in case of air, what will be random motion will be more. Random motion will be more. So what will be happen? Your particle to particle attraction, that is the collision, will be happen more. So what will be happen? The viscosity in case of gas will be increase, but in case of your water will be decrease. So option D is correct for that. Because for honey, your when we will compare the water and honey, what will be happen? The viscosity of honey will be more because of the particle between honey to honey, what will be very very close, but in case of water it will be far. It will be far. So now moving ahead on the question number 6. The continuum approach in fluid mechanics is valid when the compressibility is very high, the viscosity is low, the mean free path of the molecule is much smaller compared to the characteristics dimension. So, and the D option, when the Mach number is very very much than 1, where m is the Mach number. So which option is correct for question number 6? So please try to give the answer for this question, question number 6. I have another questions also. Let me open the questions. So Mukesh is telling option C. Yes, option C is correct for that. So I have new questions also. Let me share with you new questions because I have discussed such type of question in the previous year. So yes. So the question is visible, please. Question is visible. Yeah, not clear, but because answer is given below, so that's why I have a little bit increasing the font size. So the question is, what is the fundamental hypothesis in engineering fluid mechanics? Whether it is continuum, discrete, depend on the type of fluid, none of the above. Yes, someone telling the continuum. Okay, this is the fundamental hypothesis of engineering fluid mechanics. Okay, Mukesh is telling option A. Okay, good. Anyone want to participate? Okay, Solanki is telling option A. Okay, Smith is telling the okay, continuum. Yes, continuum is the hypothesis, that is the fundamental hypothesis of the engineering fluid mechanics. Let me reduce the size. Okay. So the your second question, this is, let me take the pen. So this is your second question. Let me reduce the thickness. Okay, the concept of no slip boundary condition is applicable. The concept of no slip boundary condition is applicable at wall boundary, the interface of the fluid and solid wall, the interface of liquid and gas, the interface of light liquid and heavy liquid. So this is the very basic question. Option B. Everyone telling the option B is correct. Okay. So at the interface of fluid and solid wall. Okay, this is the correct one. Correct, correct. So option B is correct. Why? Because here is in option A is telling only wall boundary. So at wall boundary we cannot apply. At the boundary, at the interface of fluid and solid, this is the appropriate answer. If option B is not given, then option A may be correct. But if the appropriate answer is given, then you need to go with the option number B. That is the appropriate answer. Now moving ahead on the next question. Next question is telling, anyone want to tell something? Okay, next question is, choose the most appropriate options. Choose the most appropriate options. Option A is telling fluid can resist tangential and shear stress by a static deflection, but solid cannot. Solid can resist a tangential and shear stress by a statical deflection, but fluid cannot. Solid and fluid can resist tangential or shear stress by a static deflection. Option D, solid and fluid cannot resist tangential or shear stress by static deflection. So this is a very basic question and very conceptual question. Such type of question you can expect in the GATE exam also. Yes, I will explain. Okay, Abhijit telling option B. Anyone want to tell? The most appropriate options. Fluid can resist the tangential and shear stress. Tangential and shear stress, tangential or shear stress, it means tangential and shear stress is same. By a static deflection or solid, but solid cannot. Solanki, if you want to tell something, you have raised hand. Okay, by mistake I think. Option D, someone telling. Kedar is telling option D. Benito is telling option C. Okay. The different. Papu Soni, you want to tell something? You are not audible. Please just mute your. Just unmute. Okay, so option D, C, okay, let me explain little bit. Oh, so the most appropriate option, you're in fluid, actually you know already the definition of fluid. What tell? The definition of fluid is shear stress of fluid cannot resist any shear stress. Any shear stress. A fluid cannot resist any shear stress. If you will apply shear stress or tangential stress, what will happen? It will be deformed. It start deform. But in case of solid, if you will apply shear stress like that, what will be happen? It will be deformed, little bit deformed by the static deflection. Deform, and maybe deformation will be for a long period. So a static deflection. So hope I think you will get my what I want to tell. So in fluid you cannot apply the tangential. You can apply the tangential, but your fluid will not deflect. It will be moved. It will be deflect, but not a static deflection. You know already. Deflection is here is written the static term. Deflection will be happen, but a static deflection will be not happen. So which option will be correct? A fluid can resist the tangential, not. Solid can resist tangential or shear stress by the static deflection, but fluid cannot. Yes, it is correct. Option B is correct for that. Solid can resist the tangential or shear stress by static deflection, you know already. But in fluid you cannot. Your fluid, just you can you can do experiment also. In a solid body you can take the some iron body and you can just hammering. When you will hammer, what will be happen? Your deflection will be in iron, your deflection will be happen, and your deflection will be for a long time. So but in case of fluid, there is deflection will be happen, but static deflection will not happen. So hope I think which name, Mukesh Kumar, you got it what I want to tell. Okay, now moving ahead, question number 4. So option C, someone trailing. Okay, I think hope everyone got it. Now moving ahead, question number 4. So question 4 is nothing but explanation is also given. Okay, so the question 4 is select the best choice when gas and liquid are stored separately in unconfined containers. Unconfined containers means what? Container unconfined means such type of container is unconfined. Such type of container is confined. Close from up, close from down also. Such type of container is confined, and this is unconfined. When the gas and liquid are stored separately in unconfined container, here is liquid and in this container is gas. So what will be happen? Gas can form a free surface, but liquid cannot. Gas and liquid can form a free surface. Gas cannot form a free surface, but liquid can. Gas and liquid cannot form a free surface. Which option is correct? Whether option A, B, C, D. Just please little bit think and you can give the answer very easily. Option C, someone telling. Okay. Benito is telling, Azit also telling C. Okay, that's good. Because when you will put in open container gas, what will be happen? Your gas will be, your gas cannot form the free surface. But in a glass, when you will put the water, your water will form a free surface. So hope I think you got it. Now moving ahead on the next question. So option C is correct for that. Okay. Option 4. Question number 5. the dynamic viscosity of liquid dash and kinematic viscosity of gas with increase in pressure. Here is the pressure, here is not temperature. Dynamic viscosity, we are talking about here the dynamic viscosity of liquid and kinematic viscosity of gas, not dynamic. And we are not talking here the temperature, we are talking here the pressure. So please think and just fill the blank. Or you can write the whether option A, B, C, D, which one is correct. Other participant also think. Sara is telling A, Solanki. Okay, please just write another person. Solanki is telling C. Jasprit Singh is telling option A. Kedar is telling C. Okay. Diksha is telling A. So whether your dynamic viscosity of liquid will increase or decrease with pressure? The question is, oh, your dynamic viscosity will increase, will decrease or increase? Which one is correct? If dynamic viscosity of liquid, L for liquid, whether this will be correct or this will be correct. Which one? If your pressure increasing. Kinematic viscosity of gas increase or decrease or remain same if pressure increase. So this is the question. So many people telling the option A, B, C, someone telling C also. So what will be the exact answer for this question? The exact option is B. Remain the same. Your dynamic viscosity of the liquid, when it will be increase the pressure, your dynamic viscosity will be same, and your kinematic viscosity of the gas will be decreases. That is this option is correct for that. How? Here the description is also given. Here the new questions, description is also given. The dynamic viscosity of liquid depend on the molecular cohesive force, which depend upon the temperature and generally not a function of pressure. You know already. Hence, with increase in pressure, the dynamic viscosity of liquid remains same, whereas the kinematic viscosity of gas is the ratio of dynamic viscosity and rho. So this is like that. The relationship is this. And your rho is equal to what? Rho is equal to mass divided by volume. That is your density. With increase in pressure, volume decrease. If you will increase the pressure, what will be happen? Your volume will be decrease. Your volume will be decrease. If your volume will be decrease, what will be happen? Your rho will be increase. If your rho will be increase, what will be happen? Your kinematic viscosity will be decrease. Because you know already, if the relation like that, if this thing will be increase, this one will be increase. If relation like that, what will be happen? If this will increase, this will increase. So indirectly proportional to or indirectly proportional to, such type of things happen. So here if you want to write the actual, what will be happen? Your mu and this is mass, and this is volume. So your mu is related to mu volume m. So when your pressure will increase, what will be? Your volume will be decrease. So your kinematic viscosity will also be decrease. So hope I think everyone got it. Okay. Now moving ahead with the next questions. Question number 6. Okay. The variation in the volume of liquid with the variation of pressure is called viscosity, surface tension, bulk modulus, and the compressibility. The variation in the volume of liquid. Variation in the volume of liquid. Initially volume was like that. After that your volume reduces, after that volume reduces, after that volume reduces. Maybe initially volume was small, increases, like that also you can think. But here is the question is the variation in the volume of liquid with the variation of pressure is called what? Viscosity, surface tension, bulk modulus, and compressibility. So everyone telling option D, yes, it is a very basic concept. Option D will be correct for that. Now moving ahead on the next question. Next question is formula you know already, compressibility formula. This is not a big concept. Now the question is, okay, question 7. The shear stress variation of fluid A is shown in the below figure. The fluid can be identified as ideal, dilatant, Newtonian, or rheopactic. Which option is correct for that? Oh, very basic question. Okay, Solanki is telling option C. Mukesh also. Kedar also telling. Jasprit also telling. Anybody want to participate? Okay. Simranjit also telling. Okay. So everyone is telling option C. It means option C is correct. Now the next question is, so how this will come if I tell you, you know already the y equal to mx plus c. The so this is your c, your line is like that. If this is y and this is x, y is equal to mx. So your equation like that, your graph will be like that, y and x. So here is the same thing. Tau is equal to nothing but your something is du by dy, you can write also. So what will be happen? So here is y, so this is y and this is m and this is x. So at x you can put the shear strain, that is du by d theta by dt, or you can du by dy also, and here is your shear stress. So you're like that, your graph will be like that. So now the next question is question 8. Very easy question. A liquid has a viscosity of 0.003, that is your dynamic viscosity we are talking about. Here it is not written dynamic viscosity, but you can guess through the given unit. 0.003 in Newton second per meter square. A specific gravity is given. specific gravity is given 0.85. The kinematic viscosity of the given question. Please, whether option A, B, C, D, which one will be correct? Just please, you can solve through your calculator and tell me the answer. Just please try to solve through the calculator. Just open your calculator, or you can also use your mobile. Okay, Azit is telling C. Solanki is telling C also. Okay, let me see which option will be correct. I will wait 1 minute, another 1 minute. Okay, Kedar is C telling. Benito is telling option B. Okay, everyone telling is option C. Okay, let me see. So what you will do, just you know the, where is the pen? You know already the formula of your kinematic viscosity is nothing but dynamic viscosity divided by rho. So how you will calculate? The dynamic viscosity is given rho. How you will calculate the rho? That is the specific gravity into 1000. So it will become 850. So just here divided 0.003 divided by 850. So it will become, let me see, this 3.54, 3.53 10 to the power 6. Okay, this will be correct. Okay, now moving ahead. Option C is correct. Okay. Now the question 9 is telling, question 9, an ideal fluid is defined as a fluid that is incompressible, compressible, has a negligible surface tension. D is the compressible with inviscid. Is incompressible and inviscid. Option D. Okay, everyone telling option A, option A. We are telling here ideal fluid. Ideal fluid. Here the two term is given. Okay. Okay. Now Jasprit is telling option D, that is incompressible and inviscid both. Okay. Any other? Any other want to tell? Kedar is telling D. Okay. Anyone? Anyone want to tell? Okay. Smith is telling D. Okay. Most of the student is telling A, D, but now many student telling D. Okay. So yes, your option D will be correct. Now moving ahead on the question number 10. So question 10 is about 1 liter of petrol weighs 702 Newton. Calculate its specific volume. Now just please try to give the answer of this question. You have 2 minutes. Okay, option D is correct for the previous question. Thank you everyone for your participation. Option C is telling, okay, just you have 2 minutes. After 2 minutes, I will tell the answer. Try to solve the question number 10, everyone. 1 liter of petrol weighs 7.02. So calculate the specific volume. What is the specific volume? If not know, then you can guess through formula also. What is the formula is given? Just please try to solve everyone. Then after question 10, we'll take some 5-minute break. And after break, I will start again with question 11. 5-minute break only for water and tea, whatever if you want to take. After that, we'll move with the question number 11 after 5-minute break. So please try to solve everyone. Option B, option C. Okay, other person. Very interesting question. This is very interesting question. 1 liter of petrol. Just imagine 1 liter of petrol having the weight 7.02. So are you able to calculate with this data the density of the petrol? If you are able to calculate the density of the petrol with this data, 1 liter and the weight, so you can easily calculate the specific volume, because the specific volume is nothing but just 1 by rho. Specific volume is equal to 1 by your density. So if you will calculate the density, then you can give the answer very easily. Okay, many students, many friends are giving the answer, but I want the answer from everyone. Okay. Okay, let me show you the answer. So 1 liter means nothing but your 1 liter is 0.001 meter cube, and weight is how much your Newton is given. Weight is given 7.02 Newton. So you can write weight is equal to mg. So your mass is equal to 7.02 divided by 9.81. So this will become something like x. So now you can calculate rho very easily. Rho is equal to what? Mass by volume. So mass is x after calculation, and volume is 0.001. So this is your density. For a specific volume, what we will do? 1 by rho. This will be the correct answer. So the correct answer is here, rho is equal to 7 point something. Your correct answer will be 1.39 into 10 to the power minus 3. 1.39 into 10 to the power minus 3. So option B is correct for that. So how many students? Yes, everyone telling the option B. That's good. So we'll take 5-minute break. After 5 minutes, we'll start with the question number 11. Let me show you the question number 11. If anyone want to solve, you can solve the question number 11. But I will take the 5-minute break. Question 11. After 5 minutes, I will come back. Now we'll start. So question 11 is what? Let me read. Some of the participants telling option C. Okay. Azit telling, Jasmita telling, Spirit telling. Okay. Let me just read question for other person. When the pressure of liquid is increased from 3 to 6 mega Newton per meter square, your pressure is increasing. P1 was 3, after some time 6 mega Newton per meter square. So total increase how much? 3 mega Newton per meter square. Okay. Its volume is decreased by 0.1%. Let's suppose previously your V1 was V, V2 is decreased by 1%, means what? 0.99 V. Decreased by 0.01, not 1%. Here, so 999, I think. Yes. Okay. What is the bulk modulus of elasticity of the liquid? K is what? The bulk modulus. The bulk modulus is nothing but, you know already, change in pressure divided by change in volume. So like that you can, change in volume is this, and change in pressure is 3 into 10 to the power 6, that is mega Newton per meter square, and the change in volume 0.1. So it will become around your 3 divided by 1% means what? 0.100. Here this 1000 will come above, 10 to the power 3, already 10 to the power 6 is there with the 3. So 3 into 10 to the power 9 mega Newton per meter square. Megapascal, it is asking in the megapascal. So megapascal is nothing but 3 into 10 to the power 6 into 10 to the power 3 Newton meter square. So this is the mega. 3 m Newton per meter square. So you can write 3000 mega Newton per meter square. So like that. Question number 12. Very, very important. A U tube is made up of two capillaries of bores 1 mm and 2.2 mm respectively. The tube is held vertically with zero contact angle. D1 is given you 1 mm, D2 is given 2.2 mm. It is partially filled with liquid of surface tension 0.06. Surface tension is given 0.06 Newton meter. If the estimated difference in the level of two meniscus is 7.5 mm, determine the mass density of liquid. You need to calculate rho. If difference is given 7.5 5 mm. So how you will approach this question? Just please you take 5 minutes for that. Very important question. You can expect such type of question in the coming your assignment and other examination, gate and other examination also. Question number 12. Just please try to solve the question number 12. Okay. Some student telling the option A. Okay. But please try to solve such type of questions. Other participants also. So if anybody know the formula of capillary rise, then very easily you can give the answer of such type of question. Okay. Option D is telling Sahid. Another student. 5 minutes you have. Please everyone try to solve, because if you are going to give any exam, competitive exam, if you will not solve here, because here is not any pressure on you. In exam hall, so many pressures. I have given lots of exam also, so I know very well. So if you will not take attempt here, then you cannot able to solve such type of even similar question in your exam also. So just please try to take the attempt. If you will able to take the attempt, then you can solve any type of questions. Whether your answer may be wrong or may be correct, doesn't matter. But you can understand the question and you can solve the question if you will take attempt here to solve the question. So please try to solve the question and give the answer and write the answer in the chat box. So Alanki Prince is telling A. Okay. Asprit is also telling A. So just you have 1 minute more. Please try to solve the question number 12. You need to calculate the density. I can give the hint for other participants. Just you will write the capillary rise formula H1, then again H2. The two diameter is given and the difference between H1 and H2 is given 7.5. Surface tension value is given. So only your unknown value will be rho, that is the density, and you can calculate very easily. Okay, most of the aspirant is or most of the student is telling option A is correct. Let me check. 1780. Okay, option D is coming closer. Oh, how you will solve? You know the formula already. H1 is equal to what? For your sigma is given for surface tension, rho ZD. Your cos theta will be not considered here because theta is 0 already given. So here H1 minus H2 for sigma, because sigma is same for both and rho also for same for both. G also 1 by d1 minus 1 by d2. So you put the everything for sigma 0.06, you need to calculate, and h1 minus h2 is given already 2. Let me see, 2.2 minus 1, so 1.2. 1.2 into 10 to the power minus 3, because in given in the mm, 9.81, and d is given in mm. So how much mm? Oh, no, no. Your difference is given 7.5 and d1, d2 is. So here 7.5. 7.5 mm. Here d1, 1 into 10 to the power minus 3, 2.2 into 10 to the power minus 3. And when you will calculate, you will get your rho is coming around this much. So hope everyone got it. Now moving ahead on the next question, that is question number 13. Yes, please. Now visible? Now visible? Yes, you just need to remember this formula very easily, because h1 minus h2 when we will do, then d1 minus d2, because everything here is the same. If the same, you can take the common. Now moving ahead, next question. Next question is about a soap bubble 60 mm in diameter has an internal pressure in excess of outside pressure of 25 Pascal. So what is the tension in the soft film? So just try to solve this question. Then I will just initially you can take the put your mind. Okay. For question number 13, whether A, B, C, D, which one is correct? Sahid, you are telling the B option is correct for question 13. Okay, okay, yes, yes. Okay, we'll see. Let me, other participant, please try to solve such question. This question. Okay, Asprit is telling option B. Good, good. Another student, please also try to solve. You have the 2-3 minute or 5 minute you can take also, because some students are very new students, some students are very practice, previously done the practice on such type of questions. So for newcomer, you can take 5 minute, no problem, because here you can take the more time, but in the exam hall you cannot take the more time for such type of questions. So you have 5 minute. We are talking here about the soft bubble, not a simple bubble. 60 mm in diameter, has an internal pressure in excess of outside pressure of 25 Pascal. Okay, Azit also telling, and Jamita also telling option B. Okay, everyone telling B. Let me see the answer of the another participants also. Okay, well, everyone doing very well, but other participants need to participate in the question answer session. Whether it will be wrong or correct doesn't matter, but you try to participate in the question answer session. Then it will be very successful. Otherwise, I will show question and answer. There is no meaning. But some students are very active and try to give the answer of each questions, so other participant can also participate. Okay, Mukesh is telling option B. Okay, so let me show you the answer, or I can wait 1 minute. Maybe a new student try to solve, so I can wait 1 minute also. Okay, Muthu is telling option B. Okay, I think everyone telling B, it means B option should be correct. Let me check. Yes, option B is correct. The formula is delta P is nothing but difference in the pressure from outside and inside. So 8 your tension divided by D. So D is nothing but 2R, that is a radius. So 40 by R. So this is given 25, and you can calculate T very easily. So it will become this much, 0.1875. So option B is correct for that. Now question number 14. Question 14. It is observed that water at 20 degrees Celsius rise to 15 meter in height in a tree due to the capillary effect. Let's suppose a tree is here. At 20 degrees Celsius, water is rising in the from root, it is rising up to the 15 meter in a tree. The surface tension of the water is given already 0.073 Newton per meter. The contact angle also given 25 degrees Celsius. The maximum diameter of the tube in which water rises. So what is the maximum diameter of the tube? D max. So you can take 5 minutes here also. So please try to give the answer of such question. Option D, okay. Sahid is telling option D, okay. Another participant also try to give the answer. Oh, this is visible. Oh. So option D telling, okay. Jaspreet is telling A, okay. Simranjit is telling D, okay. Arshpreet is telling D, okay. Everyone telling D. Might be D will be correct, but I will wait 1 minute for new students. Okay. So let me show the answer. So here similar you will write the formula, you will apply the formula, your rise in height is equal to nothing but your 4 sigma cos theta divided by rho ZD. This formula will be applicable. So this is. And how this formula come? So you know already, if your capillary rise here, let's suppose water is rises up to that much. So whatever the force will be here and weight. If this is theta, then this component is what? Your force, that is the tension force cos theta. And it is x. So your weight of liquid what? Mg. Mg means what? Rho. Rho is equal to m by v. So m is equal to rho into volume. So rho volume g. So your rho volume how much? Volume pi by 4 d square into height. Because if you want to calculate the weight of this, so area and height. So volume and g. And the area of surface tension how much? The perimeter. So pi d. So when you will equate these two things, then you will get the formula D is equal to like that. So when you will put, you will get the final answer 0.0018 mm. So option D is correct for that. Okay. Thank you everyone. Now moving ahead on the next question. Next question is about the suppose that the oil is seared between two very close plates. The distance between 1.5 centimeter. Very close plate and the distance between two plate is 1.5 centimeter. Okay. So suppose, okay, one is fixed and another is moving. At 3, let's suppose this is fixed and this is moving with the velocity 3 meter per second. Compute the shear stress in the oil. You need to calculate the shear stress in the oil. If the dynamic viscosity of the oil is given 0.29 Newton second per. So such type of question you can expect in the exam, GATE exam or the previous year or so. Please try to give the answer. Okay. Option C telling. You have option D also. Option D is 60. So if your answer comes 60, then you can write option D. Okay, C. Jasprit is telling C. Okay. So this is very basic question. You have 4 or 5 minutes for that question also. Okay, another participant also try to give the answer. So for hint, I will tell you you can apply here your basic concept. Shear stress is equal to dynamic viscosity and rate of deformation of your oil. But here it is very thin layer, so you can write at the place of du by dy, you can write directly velocity divided by your distance, that is the height between two plates. So this is the hint. Okay, most of the student telling C. So please another participant also try to solve. Only 4 participants or 5 participants are telling C. Okay, Mukesh also telling C. I will wait 1 or 2 minutes. Just please try to solve. Then after I will move on the new questions. Any other participant want to tell? Okay, let me show you the answer. So 58. So how you will solve? Like that. Your tau is equal to mu du by dy. But very thin plate you can write directly mu and your velocity divided by y. So your mu is nothing but 29. Velocity is 3. Let me write here. Mu u by y. So 0.29 into 3 divided by 0.015, because it's centimeter, you will convert in the meter, it will come like that. So 58 Pascal. So that's good. Thank you everyone. Now moving ahead on the next question. Next question is this. Hope I think it is visible. Oh. So the first question is, a fluid occupy 12 meter cube, that is the volume occupy 12 meter cube. Calculate the specific volume in kg per meter cube if the fluid mass is 8 kg. So this is the similar question previously, but here is the digit is changed and some concept is changed. Just try to solve and try to give the answer of this question. Please everyone try to participate. You have 1 or 2 minutes. Okay. Mukesh is telling D. Ajit is telling D. Okay. Another participant want to tell something? Okay. Option A, option D. Jasprit is telling option A. And this is a similar question like previous. So how I will solve? Let me show you. The volume is, let me take. The volume is given already 12 meter cube. Specific volume you need to calculate. Mass is given 8. So it will become 1.5, but how? The specific volume, here it is written a specific volume, but unit is given like that. So this is the density, is nothing but density is your 12 by 8. So this is kg per meter cube, but it is density. But in the previous question we have already seen the specific volume is 1 by rho. So here need to correction, but if the question is volume, that is your if you want to calculate your density, then 12 by 8, so it will become 1.5. Okay, here need the correction. Now moving ahead on the next question. Next question is a ideal fluids. This question we have already solved. This is the definition. A small shear force is applied on an element and then removed. If the element cannot regain its original position, what kind of an element can it be? Whether it is solid, liquid, fluid, gas. A small amount of shear stress you have applied. Which one is appropriate actually? Here more option may be correct, but appropriate you need to select. Or you are telling Smith is telling A. Okay. You just try to read the, okay. Ajit is telling fluid, that is option C. Just please try to read the question, then you try to give answer. Any, please, I am telling to everyone. Solid, liquid and gas. Okay, but you need to select the appropriate. Okay, C. C, okay. Banito is telling C. Jasprit also telling C. Okay, good. So most of the participant is telling C. Definitely your C will be correct, because as this is the definition of the fluid. So question 4 is nothing, is the very important. A hydraulic press has a ram of 30 centimeter diameter and a plunger 3 centimeter diameter. It is used for lifting a weight of 60 kilonewton. Find the force required at the plunger. That is, here you need to calculate the force in kilonewton. Weight you need to lift a weight 60 newton, 60 kilonewton. So please just think on the question and try to give the answer. You have 4-5 minutes. Okay, option A is telling esprit. Okay, good. So everyone please try to give the answer. So other participant also please try to give the answer. Okay, Ajit is also telling Ajit A. Okay, another participant please. Okay, Jasprit is telling C. Smith is telling C. Okay, okay. Sahid is telling A. Anyone want to tell? Okay, Mukesh is telling A. Simranjit is telling A. Okay, good, good. Let me show you the answer. So A option is correct for that. How A will be correct? So here you have the let the force at the plunger is F1. Okay. From the Pascal law you can write. What you can write? Let me explain very briefly. So if you want to lift anything, weight, let me, this is the 60 Newton, kilonewton weight. With a ram and a plunger. So you can write here the diameter of the ram is, you can make the graph figure like that. So this is a ram, you can say this diameter is 30 and here you have the plunger. So this plunger diameter is 3 and ram diameter is your 30 centimeter. So how much force is required here to lift the things? So this force area, your force is how much? That is F1 divided by area, pi into pi by 4 you can write into d square, that is 3 into 10 to the power minus 2 whole square. Similarly 60 kilonewton, So into 1060 Newton divided by area. So pi by 4 into 3 into 30 into 10 to the power minus 3 whole square. So when you will calculate, you will get the 600 Newton or 0.6 kilonewton. So this is the whole idea. So now moving ahead on the next question number 5. Okay. The equivalent head of mercury corresponding to 4 kilopascal is, take the specific gravity of mercury is 13.6. So you have the head or pressure head, you can head, not maybe pressure or whatever, 4 kilopascal. So corresponding head in mercury, what you will get? So this is also important question, try to solve. For question number 5, okay, please try to solve such question. Please try to solve this question. Okay, Esprit is telling, I think option A. Okay, Ajit is telling A. Jasprit also A. Okay, everyone telling A. Okay, you have 1 minute more if anyone want to give answer. Simranjeet A, Sahid Alam A, everyone telling A. It means A option will be correct. Let me see and let me show you. Yes, A will be correct. Nothing, formula is very easy. Okay, now moving ahead on the next question, question number 16. 6. A specific weight of seawater is more than that of pure water because it contains dissolved air, dissolved salt, suspended matter, all of the above. Which option is correct? Everyone please think. Option B, okay. Okay, option B. Jasprit, Asprit, both are telling option. No, no, no. Jasprit is telling option B. Asprit is telling D. Simranjit is telling B. Okay. Another participant. Muthu telling D. Okay. Maybe D. Okay. Okay. Now everyone correcting. Okay, Esprit is telling D. Okay, good. Yes, option D is correct for this question because everything possible, the possibility of dissolve air, dissolve salt, dissolve suspended matter in the sea water. So every will be correct. So this is the last question for today. So please try to give the answer of this question. Which of the following is the dimension of mass density? This is the last question. Option A, okay. Okay, everyone telling option A. Let me move ahead on the next question. Okay, that's good. Yes, option A will be correct. This is the very easy question also. Surface tension is what? Everyone please give the answer for this question also. For question number 8. Act in the plane of interface normal to any line of the surface, also known as capillarity, is a function of curvature of interface decrease with fall in temperature. Okay, everyone telling is A for that A. Okay. Yes, option A will be correct for that. Okay, you have 1 or 2 minutes. Let me move ahead on the next question. The question 9 is telling for a compressible fluid, does density vary with temperature and pressure? For a compressible fluid. Just please try to give the answer. So this is little bit tricky question. So you have 1 minute or 2 minutes. It varies for all temperature and pressure range. It remain constant. Here is the incompressible. It varies only for lower value of temperature and pressure. It varies only for higher value of temperature and pressure. Okay. Someone telling A, someone telling B, Saeed Alam B, Simranjit telling A. I will show you answer, but just I need some another participant also try to give the answer. All, okay. Muthu and everyone telling A. Okay, let me show you the answer. So option B will be correct. It remain constant. For an incompressible fluid, incompressible, the change in density is negligible because you know already. Thus, it does not change with temperature and pressure. It remain constant. Always remember, please, because you have already written the incompressible fluid. So remember, always read the question very carefully. So thank you all for today. So we'll meet again on next Monday, 6 to 8 p.m. So thank you all. Bye bye. If you want to share anything, please you can share within 1 minute. Then I will close the session. Okay, bye bye. Thank you. Thank you. Welcome. Yes, please. You want to access this question? Okay, I will upload. I will upload on the link. So you will get the link from NPTEL. NPTEL side you will get. NPTEL send you. Oh, sure, sure. Yes, please. Yes. How can connect means you want to ask question? Okay, okay. Let me share my mail ID. You just write down OP Maurya. Everything. Okay, okay, okay. I will send my mail ID. You can mail me any type of questions. Okay. So OP Maurya IIT14 at the rate gmail.com, and another mail ID also OM1996 itc.ac.in. So I am Om Prakash Maurya from IIT Guwahati Department of Civil Engineering. So I have mail ID, two mail ID. You can send me question on any mail ID. So thank you all for today. Anything Mukesh you want to share? Sure, sure, sure. Okay, thank you. Thank you everyone. Thank you for today, your contribution and your answer and everything. Thank you all. Now I will disconnect them. Okay, bye bye. Good night.